Welcome to 4647 video. Today's video is filmed in front of a live audience. Alright, let's get into it. We have to take notes on this because I tell you to do so. Don't you agree, class? Alright. Anywho, we're looking right now at a little picture. So you draw this picture right here. It's called a hypotenuse leg. It's a special type of triangle. The hypotenuse, as you notice in this picture, is right across from the right angle, and the other two are called legs. So that's really great. Moving on. Anywho. Alright, so as you can see, our essential understanding for this section is you can prove two triangles are congruent without having to show all corresponding parts are congruent. So we've actually done this before with angle, angle, side, and angle, side, angle, and side, 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 and side, angle, side. Okay? The last one's called HL, it's hypotenuse leg, and if we can show that the hypotenuse and leg are congruent from one triangle to the other triangle, then I can prove the triangle is congruent. So we want to make sure that we write this down. Okay? And not only that, but we can kind of go and look at this too. So go ahead and pause the video, write this down. We also have key conditions for HL to be true. There has to be two triangles. The triangles have congruent hypotenuse and one pair leg. Now, this is great. Obviously, that's already met in our first one, so you do not need to write that piece down. Isn't that great? All right. Let's move on to one of our first problems using HL theorem. Look it, it's a basketball hoop. Anywho, I gotta move my face. Okay. Anywho, looking at this basketball hoop, let's get the picture up here and now we can take a look at it. It says, on the basketball backboard shown, we have two triangles. They're right triangles. It says AC is congruent to BC. Are the triangles congruent? Well, they tell us that they're right triangles, so first we mark that AC is congruent to BC, so we have AC, boom, and BC are congruent. It tells us that they're right triangles, so we can go ahead and fill in the right triangle being here. Okay. Notice that the two sides they gave us are actually called our hypotenuses. They're across from the right angle, so this is the hypotenuse directly across. Okay, awesome. And as we move forward, we're going to go ahead and show that these two triangles are congruent. They obviously both have a hypotenuse. When I'm looking at hypotenuse leg, the H is there. Then we also have to get a leg that's congruent. And notice that they share CD, so we can actually go ahead and use HL. So we know these two triangles are congruent. So I just finished this statement basically by saying triangle ADC is congruent to triangle BDC because of HL theorem. Alright, you guys did awesome. Give yourself a round of applause. In 4.7, we learn about triangles that might overlap each other, and I think things that overlap are just hilarious. I mean, what do you get when you cross a tree and exactly. Okay. So sometimes we can prove corresponding parts of congruent triangles, but we have overlapping triangles. So the key is we're kind of looking at this part of overlapping triangles. So let's go ahead and jump right into some example problems. Okay. The first problem here is we see that these two triangles share common pieces, not almond pieces, because almonds are hilarious. Anywho, as we can see, the triangle is right here, ACD. It would be best for us to go ahead and actually draw ACD out by itself. So there's A, C, and D, and then draw triangle BEC out by itself. And when we do this, we can actually see what they share in common. And so we can see that the angle C is shared right here. So we know that that piece is going to be congruent to that piece. And then when we're looking at other things, we can't see anything else that is congruent, but we've missed a lot of confusion here by having an overlap. So a lot of times we want to separate the triangles out first so we can see a little bit clearly. So what common angle do they share? They're going to share common angle C. Would you guys agree?
Yep.
All right. Let's take a look at another problem. All right, this last one's a proof, so this was what we'll end with right here. We have given a couple pieces of information. We want to prove a last piece of information that these sides are congruent. The best thing for us to do is actually go ahead and try and separate these pictures out. And so when we separate the pictures out, we can see them a little bit more clearly. So we're going to kind of just pull this along, and let's separate them out and pause right there, okay? And as we can see, you guys don't have to write all this down. We'll do the proof in a second. But it says a diagram of the triangle is separated right here. So here's our picture that we go ahead and separate. And we can see that we have the angle X and angle Y congruent. And we have angle this X over here congruent to this angle W over here. Okay, sorry, X and W. So those pieces are congruent to one another. And we have two angles. And we want to show that these two triangles are congruent. And the third side that we can show is going to be WX. So we're going to use W and X as the congruent side that they share. And as we kind of go forward and move through this proof, we can go ahead and draw it off to the side. So let's go ahead and now start our given. And I got to move my face again because I'm always in the way. Yeah, it wasn't that funny, was it? Okay. Anywho. So let's go ahead and let's get our statements and our reasons, and let's get this filled out. Okay, so statement one, a lot of times we want to go ahead and do a lot of our given information. So we're given that ZXW is congruent to angle YWX, and then we also have angle ZWX is congruent to YXW, which is a lot of letters there. And the reason is given. Okay. So those angles are represented right here in our picture. This is our ZXW is right here, and then we have YZX is this one right here. Or YWX, sorry. So we have two angles proven, so we want to go ahead and always mark our angles that we know. So we have angle and angle. And then we just got to prove one further thing, so step 2, didn't mean to change the color. These two are congruent because they're overlapping in this picture. So we can say WX is congruent to WX. And that's going to be because of reflexive. Thank you, studio audience. You're doing such a good job of being quiet. I appreciate it. Is there anything you'd like to say?
Love you, sister.
You're supposed to laugh. Super awkward. Anyways, yeah, you guys are revolting. You're like, this is actually not as fun as we thought it was. The funny thing is the studio audience can't even see what I'm doing, so they just hear me talking to myself and probably think I'm going insane. Anywho, but we can all appreciate someone going a little bit crazy, right? Okay. All right, number 3, we've proven now the triangle congruent by angle side angle. We got to make sure that we line up the appropriate angles for each piece, okay, because we got the 2 angles in the side. So we're going to go ahead and line this triangle up. So our triangle congruency statement has to be accurate. So X is going to go ahead and line up with W. Well, first one we'll do XWZ, that's fine. And then when we line it up with the other triangle, we're going to get W with X, X with W, and then Z with, that's going to be Y. So sorry about that, slight error. Okay, so we get angle side angle, and then last step, we can prove that these sides are congruent. ZW is going to be congruent to YX, and that's because of CPCTC. So there you go, that's it. That's the video. Hope you guys enjoyed it. We could get a round of applause. Thank you. Thank you. and if I had a great joke, I'd give it, but I don't know any great jokes. Does anyone know any great jokes?